something else, another emerging technology that you've talked about in a blog post we caught is talking about quantum computing. So I wanted to get into that a little bit. In an article you noted, and we'll have a link to this article, it's in something called Diginomica. And so we'll link to that so people can read it in full. But you note that connected operations platforms already do many things that transport reimagines, and that quantum computing may continue to enable this by crunching, quote, unimaginable amounts of data. So you talk about something that would today, take a traditional compute platform 10 septillion years can be done in minutes with quantum. So tell us about what quantum might be able to do in your space around routing, predictive maintenance, scheduling, and go ahead.
Yeah, I think for when you really think about it, right, like a very practical example is like routing and scheduling, you could say, right? I'll give you an example, which is like pretty much everyone who studied computer science has gone through, like the traveling salesman problem, right? It's an NP hard problem, which means like, it just scales exponentially in terms of like computational needs for you to solve it. And anybody who's trying to solve that problem effectively uses optimization techniques, right? So like in a simple sense to say is like a traveling salesman problem where you're basically saying for routing, like a vehicle has to visit 20 stops. Find me the most optimal way for it to visit the 20 stops. I do believe there are a little over, I think a lot more than trillion, I think maybe quintillion, I think is the next one, 10 trillion, like number of combinations that exist. So I think over time, algorithms, we've gotten good at approximation algorithms and then like reducing the search space of that solution space and then like coming up with answers. But I think getting to optimal solutions like for the space of like route planning is like a great opportunity with quantum. Now, we just talked about traveling salesman in terms of the one individual route problem. Now, move that along to think about, hey, like I have to make 10,000 stops. I have 15 vehicles. Find me the most optimal. Yes, you can do that. It's also a very classic, engineering problem called like the vehicle routing problem. And again, solutions today uses approximations, not like precision answers, right? Now, let's extend that 2 steps further, right? Like now we've talked about stops. Now, between stops, what happens is routes, right? Like think about it from a lens of like, I need to go from stop A to stop B. I need to parse a bunch of segments to get there. And I have options within those segments. Now the problem again multiplied to become something bigger. And let's add one more variance into it. Like every time, whenever like we all drive, we know that like we actually have real-time traffic lights. That's real-time traffic, very real thing, right? Now, lots of what we are doing is like these approximation models are like just taking some predictive examples and then like not really using closer to real-time data. And then like they're just trying to model, okay, this is what I think likely will happen. And then, right? So with technologies like, when compute sort of becomes really easily accessible and like the limits goes off, your ability to do things with much more high precision is possible, right? Like obviously with things like routing, you can get to like really high precise and like, a lot more efficiency, the gains can be like achieved. There's always the argument we can make of like, what is good enough, which I think is there's like a point of diminishing returns at some point, but like the possibilities are endless and like the different variables you can react to are pretty much endless, right? So I think what I generally think will happen is like today, a lot of the technologies we have like help you make assisted decisions. And I think that's kind of great for you to get into like a world where truly self-operating systems, I don't think we are anywhere close, right? Because like with these type of problems or like the compute capabilities plus like, the level of access to data to make real-time decisions are like limiting factors in that scenario.